AWS IoT TwinMaker tutorial. Our use case is we have a factory where there are motors running on the production floor. Production supervisors want to see a visual representation of current and historical status of these motors, specifically their speed. And this is what our overall architecture would look like. For the purpose of our tutorial, we will use one motor. On AWS Cloud, SiteWise will receive motor data. Digital twin is created in TwinMaker and visualized via Grafana. Let's begin by creating a motor model in SiteWise. In AWS console, under AWS IoT SiteWise section, select models and here hit create model. Provide a model name. We will call that motor model. Add an attribute, a name for that, serial number. Next, we will add a measurement. So that will be speed and unit as RPM and data type as double. Now, hit create model. We need to provide a default value for the attribute. So let's just call it default. Hit that create model. And here we have a new motor model, right? So there you can see the attribute and measurement definitions. Next, we will create an asset in SiteWise using the model we just created. Select the asset submenu and then hit create asset and choose the model we just created, which is the motor model, and provide an asset name, right? So this is motor 1. Okay, and then hit create asset. So that's our motor 1 asset. Now we will add an alias to the measurement. So for that, hit edit asset, come down to the measurement section and add a property alias of the form /factory /motor1 /speed. Make sure that MQTT notification status is active. Hit save. Now alias is where we send data to, right? So when we want to send data to an asset, we use the property alias. Okay. So now we are done with the asset creation. In real world, the motor would send its data to AWS SiteWise on the cloud via an IoT or Greengrass device in the factory. For our tutorial, we will use a Python script to generate and send motor data to SiteWise. Hit the Cloud Shell icon in AWS console. This will open a Linux prompt, and here I have already uploaded a senddata.py Python script. Let's take a quick look at that. So this will send randomly generated speed along with timestamp to SiteWise. At the top, you can see the alias /factory /motor1 /speed. Now let's run that file. So Python senddata.py, and it should send data with 1 second intervals, right? So there you can see a double value on the right hand side. That's the speed that is being sent. So let's come to AWS console asset section in SiteWise, and under measurements against speed, we can see the latest value, right? Let's focus on TwinMaker now. We will start by creating a workspace. While doing that, we will also create S3 bucket, roles, and policies we need. We are in AWS IoT TwinMaker section. Hit create workspace. We'll provide a name for the workspace, factory workspace, and we need to associate an S3 bucket with that. So let's create an S3 bucket. Okay, provide a bucket name. We'll call that factory WS bucket, and leave everything else as default. Hit create bucket. All right, now go back to our workspace creation and associate this S3 bucket. All right, so that is factory WS bucket. And for the execution role, we will go to the AWS IAM section. First, we'll create a policy. Okay, let's hit create policy and choose JSON and paste this JSON where we provide permissions for TwinMaker, SiteWise, and S3. Now, this is a really permissive permission. Now, for your production workloads, make sure that your permissions are restrictive and you have only what you need. Okay, now we'll give that policy a name, factory policy. Now we will create a role. Okay, so choose custom trust policy and provide this trust policy for IoT TwinMaker and Grafana services. Hit next. Okay, now choose the policy we had created earlier, factory policy. Hit next, provide a role name. We'll call that factory role. Okay, and hit create role. We come back to the workspace, and for execution role, we select the role we just created, factory role. Then hit next. And for dashboard management, we select Amazon Managed Grafana. And for Grafana authentication provider, we again choose the factory role. Hit next. And for the dashboard policy, we leave that as no video permissions. And for dashboard role, we again select factory role. Hit next. Review everything and hit create workspace. So our workspace has been created successfully. Now that our TwinMaker workspace is ready, let's add an entity to it. Choose the workspace and here we are going to create an entity. So from the menu on the left, select entities. Okay, and here hit create entity and provide an entity name. So that will be motor 1. Okay, and then choose create entity. Now it's time to add component to the entity. Select the entity and hit add component. Here we will provide the component name. We will call that motor metrics. And for type, we will select IoT SiteWise connector. And under asset model, we will select motor model. Under asset, motor 1. And we will leave all the rest of the properties as they are and hit add component. So our component has been created. So we have a new motor metrics component under motor 1 entity. Select the test component option to test this component to make sure that it is connected to the right data source. And under test, select speed time series property, provide a time range and hit run test. And you can see the data. Next, let's add a resource. A resource is simply a 3D model of the physical asset. So in our case, it will be a 3D model of the motor. A 3D model can be created using a variety of 3D modeling software, and it will be in a specific file format, for example, GLB. Choose the resource library option, hit add resources, then select choose file and select your 3D model file, hit open. Okay, so our 3D model file has been added as a resource. Next, we will create a scene and add our resource or 3D model to it. The scene will be configured to show motor data from SiteWise and update the display based on it. Select scenes on the left hand side, hit create scene, provide a scene ID. We will call that factory scene. Hit create scene. And this is our scene interface. Here we can see hierarchy, rules, and settings options on the left hand side. And if you hit the plus icon, you will see various submenus like add 3D model, annotations, etc. Select the add 3D model option and then add a resource from the resource library. So here we select the motor model that we had added earlier to the resource library and place it here on the scene. So the model will be loaded shortly. And if the model does not appear to be of correct scale, you can change that. So under transform, there is a scale property and you can change the values of that so that the model appears in correct scale. So that's our motor model. You can move it around to take a look at it from all sides. Let's explore this a bit. And on the left hand side, under hierarchy, you can see that motor, and when you expand that, you can see various sub models there. So these are sections of the motor, right? So as you move your mouse over them, you can see various parts of the motor getting highlighted. Okay, and when you select one of them, on the right hand side, you can see there is an inspector panel. Now using that plus icon, let's select the add annotation option. So this will allow us to place an annotation on the scene. We'll provide details for that in the inspector section. So we'll rename that to speed annotation, where we want to display the current speed of the motor, right? And in the markdown section, we just write speed colon and provide a markdown dollar with curly brackets, and then hit add binding option. And here select entity ID, component name, and property speed. Right, so let's change the binding name. We'll call that speed and update the markdown section as shown. Next, we will add a rule. So under the rules section on the left hand side, let's create a rule called motor rule. Okay, and expand that and add statements under it. So we provide an expression, something like speed greater than say 400. Okay, at that point in time, the target color should turn this particular color, red. Okay, and when the speed is less than or equal to 400, then the color should be let's say green. Okay, right, so when speed is greater than 400, the color is red, and when the speed is less than or equal to 400, the color is green. And we will see how to use this. Now let's go to hierarchy and expand that motor model, and under that let's select a section which we want to highlight in different colors, right? So we'll select that zigzag circular object, right? So we will turn that into red or green depending on the speed of the motor. Okay, so with that selected, we will add a model shader, right? So which will appear under the inspector section. Select the entity ID, select component name, property as speed, and in addition select the rule we just created, motor rule. Now our scene is ready. Overall, we added a 3D model to the scene and we added a model shader to one of its submodels. In addition, we have added annotation to the scene, and there are many other options that you could play around with. Now we can move on to Grafana, which is a visualization tool. Let's begin by creating a workspace in Grafana. In AWS console, we are in the Amazon Managed Grafana section, and here let's hit create workspace and provide a workspace name. We will call that factory workspace Grafana. Okay, scroll down, hit next. Okay, choose an authentication method. We'll choose AWS IAM Identity Center, and for permission type, customer managed, and we will select an role. So this is the same role that we created earlier, factory role. Okay, and hit next. All right, then hit next. Okay, review all the settings and then hit create workspace. So our workspace is being created. This takes some time. And here our workspace is ready. Factory workspace Grafana. In the IAM Identity Center, under users, let's add a user. So this is the user who will be able to log in into Grafana. So we will associate this user with Grafana workspace. So we'll call this username Joe and generate a password for that. Hit next. Okay, we also need to provide an email ID. So let's provide an email ID. Okay, confirm that. Provide a first name and provide a last name. And now we are ready to hit next. All right, hit next. Next, review all the details. Add user. So note down the password that has been auto-generated. In Grafana workspace, under authentication, assign new user. Select the user Joe. Assign users in groups. Okay. Now make this user an admin. Now go back to the Grafana workspace and here hit the Grafana workspace URL. This will open a new window and sign in here. Okay. Provide username. Next. Provide password. Sign in. Now this prompts us to set new password since the previous password was auto-generated. So let's do that. Okay, set new password. And now we are successfully logged in. Right. So this is the Grafana interface presented to us. Next, we will configure a data source. Select the data sources option to add a data source. And here filter by TwinMaker. And select that AWS IoT TwinMaker. So this takes us to a settings screen where we have to take a look at the connection details. So provide the factory role ARN. This is the role we created earlier. So provide ARN for that. And under workspace, choose factory workspace. This is the TwinMaker workspace. Hit save and test. And there you can see TwinMaker data source successfully configured. Now we can create a dashboard and panels, one for the TwinMaker scene and another a time series graph. Now go back to the home screen and hit dashboards. Select add new panel. And for this panel on the right hand side, select AWS IoT TwinMaker scene viewer. Okay. Now Let's change the title of this panel. We will call it Factory Motor Panel. Okay. Let's scroll down and under Scene, select the factory scene. This is the same scene that we had created in TwinMaker. So this scene should load here now. Okay. So that scene has loaded here in the UI. Okay. Now scroll down slightly and here under data source, make sure that it is AWS IoT TwinMaker. For query type, select get property value history by entity. Select the entity motor 1, then select component motor metrics and selected properties, select speed. So when you do that, you can see that in the panel speed shows up. Top right, hit the save option. Provide a name for the dashboard. We will call it factory dashboard. Okay, hit save. So that's our dashboard with one panel, factory motor panel. For this panel, select the view option. Now we need to send data to this particular asset. So let's do that. We'll go back to our Cloud Shell and run our program Python send data. So this again starts sending data at 1 second intervals, randomly generated data. And here on the screen, let's put the refresh interval to 5 seconds. So here you will see that a section of the motor turns green, the zigzag motor part, it turns green or red depending on the speed. So whenever the speed is less than 400, it is green, and whenever it is greater than 400, it is red. So this is working on expected lines. Back to the dashboard. Let's select add a new panel and make sure that it is of type time series. And under data source, it is AWS IoT TwinMaker. Query type is get property value history by entity, and entity is motor 1 and component motor metrics and selected properties. Let's select speed there. And here we can see the graph. And we can also change the time range. So for last 30 minutes, this is what the graph looks like. Let's change that again to 15 minutes. And how about 5 minutes to see the details in a more granular fashion? In addition, we can change the view to table view, right, to see raw data, right, as it comes in. So this is working on expected lines. Let's save the dashboard. Hit save. And that's our time series panel. So we will change the title to speed time series panel, right? And hit apply. Back to the factory dashboard. Here we can see our two panels now, speed time series panel and factory motor panel. In the first panel, you can see the speed data as it comes in real time. And in the second panel, you can see the motor with a part of it turning green or red depending on the speed. So with that, we come to the end of our AWS IoT TwinMaker tutorial.